what does a system engineer on Biosphere 2 actually do?
Well, of course, there's only been one, so I couldn't say it would be typical. Well, that was my title during the time. Of course, that's been like 30 years ago, so it's not current. But the main thing that I really did was work on making it airtight.
Okay. So pretty much the main thing for the biosphere, the most important part, I'd argue.
Well, it certainly was significant, but and then I generally kind of looked at all the other engineering that was being done, but of course there were dozens of engineers, and um, I couldn't even say that I really knew all of them. At least their main representatives I did know.
Sure, sure. Pretty big project. So you're very well known for creating the lungs structure of the Biosphere 2. And you explained in one of your lectures at Biosphere 2 that the lungs were necessary because of pressure fluctuations inside the biosphere and outside. If you allowed the pressure to get too great or too small inside the biosphere, it could actually destroy the structure itself. And you also said in one of these lectures that it was due to a lot of the flat surfaces of the biosphere. And I wanted to know, why wasn't Biosphere 2 built in a more conventional shape for a pressure vessel, like with more curves?
Well, there could be a lot of reasons. One is that it would be much more difficult and much more expensive. And for a very large structure like Biosphere 2 is, that would be especially difficult. And so even a single glass pane, of which a typical one was 5.5 feet by 5.5 feet, that would be typically flat. And so even if you made the overall structure with curvature, you'd still have a flat pane of glass, which wouldn't be curved in itself. So even that might be vulnerable to pressure problems. And then architecturally, of course, the architects had, the shape, the appearance that they had in mind. And it wasn't like making a pressure vessel, which looks very narrow in appearance. So my very early concern was the potential for damage if the pressure fluctuated. And so basically, I didn't directly come up with the idea of having lungs. I recognized the need to have some ability for expansion and contraction. And some of the ideas that I initially toyed with were making the whole building flexible.
Oh,
But
neat.
that would have been very complicated and very difficult and interfered with the overall architecture. And I was having discussions with other engineers, and in the discussions, somebody mentioned that there are large gas storage tanks. And so that then led into the idea of basically building a gas storage tank. But of course, they're rather different. They're built for higher pressure and don't have the graceful architecture that we came up with in the end, and various things. But
Gotcha.
but that's kind of how it evolved.
Interesting. Okay. Do you think today, with construction techniques that we use today, do you think a Biosphere 3 could possibly be built without the lungs, but actually able to withstand that internal pressure?
Well, but it would be the same basic problem. You'd need to make curving shapes. Um, if you drive around and see a propane tank, for example, it's not only cylindrical in regard to its length, but it also has belled ends. And even though you wouldn't have to do it exactly like that, something along those lines. And so you're tremendously restricted for the kinds of shapes you can make. And if you're doing something small, maybe that's okay. But no matter what you do, if you're going to try to do it curved, it's going to be much more trouble and much more expensive than if you find a way to provide expansion contraction.
Gotcha. Yeah, I suppose even though it is very hard, obviously, here on Earth, it'd probably be a lot harder to do that in space, for example, in orbit, because not only are you fighting against a lot more pressure, because there is no pressure outside, there's also like a lot greater temperature fluctuations.
Well, the main problem in space or even on Mars, for example, the Mars atmosphere only has about 1% of the pressure of Earth's atmosphere. So if you're going to build a enclosure on Mars for human beings to live in, they would have to have an atmosphere that was at least roughly equivalent to the Earth's atmospheric pressure. And so since the Mars atmosphere pressure is essentially negligible by comparison, you would have to have a much stronger structure. And so you would be driven to these curving shapes. And also, which gets even more problematic if you get large. And if you paid attention to that paper that I sent you, then you have a contradiction, for example, even if you have a curving shape that's sitting on a flat surface.
Yeah, yeah, I noticed
Because,
that like I had never seen one of those designs before that was in your paper. Sort of like it was an entire sphere, but most of the sphere was actually under the regolith, to sort of get that shape,
yeah,
make the ideal pressure vessel. I also noticed in your paper, it was very interesting, talking about how likely to maintain the structure on Mars, you'd have to reduce the overall pressure of the habitat that the humans are living in. But then in order to sustain those humans, you'd have to increase the percentage of oxygen. But then that comes with its own problems. As you mentioned, Apollo 1, you know, an oxygen-rich environment is very prone to fires.
yeah.
Yeah, so there's a whole lot of
Well,
complexity in that.
well, you don't have to reduce the pressure. I'm just saying that if you have a pressure that's livable for a human being, the pressure is going to be way, way greater than the outside surrounding pressure.
Yeah,
Yeah. And then it becomes a choice somewhere in there whether or not you try to do partially reduced pressure or full pressure or what you do. And then you discuss this issue of what you need a certain concentration of oxygen for people and animals to live in. And so if the pressure is reduced, but you still maintain the same partial pressure of oxygen, that means the oxygen has to be a greater fraction of the air. And that means it would be relatively rich, or maybe very much richer than a typical Earth oxygen atmosphere. And so then you have the fire issue.
yeah, I see. I see. I guess it's a lot of considerations. We should probably get started on a Biosphere 3 now so we can work all of these out.
Yeah. I
So
mean, my advocation for closed systems on Earth is that you basically make them with equivalent to Earth's atmosphere, and you just deal with the pressure fluctuations by having some kind of an appended expansion chamber that you can call generally a lung. Of course, the lung is a misnomer because your lung is intended to exchange gases. between your bloodstream and the surrounding air. You're trying to get rid of carbon dioxide and intake oxygen. And so there are the membranes inside your lungs facilitate the exchange of gases. But we just called them lungs because, just by analogy of the visible expansion contraction, but it's really a misnomer. It's not a name that would be correct if you were trying to describe what it does.
Sure, because it's just the expansion contraction, not the exchange of gases that is not good for biosphere. Gotcha. Yeah. So this is sort of off topic, but I wanted to ask about the trace gases, like helium and sulfur hexafluoride that were used to detect leaks in the biosphere. And this could just be a fundamental misunderstanding on my part, but I was curious. Helium is, as most people know, a lot less dense than our atmosphere. And sulfur hexafluoride, I looked this up, it's about 5 times denser than the main gases in our atmosphere. So I was wondering, when it comes to detecting those leaks, wouldn't the helium just go to the top of the biosphere and the sulfur hexafluoride to the bottom? And how would you get an even amount of those trace gases through the leaks to be able to find where a leak is and how big it is?
No, because the idea of them either being heavier or lighter is connected with the idea of them being as a body of gas. But because of the molecular movement of gases, they're getting mixed all the time. So, and also because of the air control system, the temperature control system, which was circulating air, they're always being stirred around. But no, I mean, yes, if you injected a plume of either sulfur hexafluoride or helium momentarily as a plume, it would tend to either rise for helium or sink for sulfur hexafluoride. But very quickly, the molecular movement of the molecules of the atmosphere would cause mixing.
Okay, gotcha. So it's like a difference between going in as a body of gas versus like atomized and individual particles moving around.
Yeah.
Okay.
Yes.
Thank you. The joints in Biosphere 2 were made flexible specifically because the building, it wasn't sure how it would settle over the next 100 years of its lifespan. And the joints were remaining flexible so that it could remain airtight.
Well, I don't actually know if that was necessary or not. And unfortunately, even though I had the idea, I didn't arrange to build in a way to observe if there was in fact any movement. So even though there was a flexible joint between two segments of the building, it would have been nice to have like connected a pointer to one side and another pointer to the other side, have them pointing at each other, and then a year later or 5 years later or 10 years later to see if they had moved a little bit relative to each other, which in hindsight, I would have done that.
Interesting.
But I didn't, and so I don't actually know the answer.
Okay, interesting. Yeah, that would be interesting to know. So I had one question about another question about the lungs. I should have ordered these in the correct order. But I think it's called flow through mode is what you told me, is the state that the biosphere is in right now, where it's not containing a pressurized body of air, right?
Well, that's what Columbia University called it.
Okay. So
but it's not flow through in the sense that there's a source of outside air at one place and there's another place where that air is then exits at the opposite end, so to speak, and that it goes through. And so really, that's a euphemism.
Sure,
It's
sure.
just, I think that they didn't want to just say they were ventilating it.
Fair enough. It's a little bit boring to say. Yeah. Okay. So when it comes to your lung structure, I've seen people taking tours of the lungs, and the pan of the lungs still seems to be raised. How does the pan stay suspended even though there isn't a body of air that it's sitting on?
It's artificially, I don't know if you saw a diagram that shows about suction above the pan.
Mhm.
Okay. Um, and actually, I don't know today how they maintain the height of the lung, but one way they could do it, and probably do or possibly do, is they operate that fan that's in the edge of the dome, and that creates a suction above the pan. And the whole idea of that little fan, I say little, but I mean it's like, I don't remember now, maybe 6 feet in diameter or something like that. Um, the whole idea. Well, I'll tell you how I got the idea. Um, Even though the idea was there to create the expansion chamber that we called lungs, I was further thinking about, well, what happens if somebody comes along and either by accident or vandalizes uh, a pane of glass in the biosphere and breaks it? Then all of a sudden you're going to have the weight of the pan resting on the air. And of course, that's a weight that's creating an internal pressure inside, all the way through inside. And so what would happen, of course, is that the air would blow out through the broken window and the lung pan would go down. It would just go whoosh, and all the air would blow out.
Huh. Interesting. So I just
Um,
didn't know that that fan was powerful enough to keep the entire pan suspended.
well, it doesn't have to be very powerful,
Hmm.
because
Okay.
all you have to do is create enough pressure, enough suction pressure um, in the whole space above, underneath the dome of the lung and above the membrane. And since the membrane is huge, it's 158 feet in diameter, and the pan is 93 feet, I think, if I remember right, 93 feet in diameter. And even though it's aluminum and weighs like 20 tons, when that's distributed over that large an area, the pressure difference between underneath and over the top only has to be the equivalent of 1/2 of an inch of water column. Uh, not very much.
That's
And
interesting.
and so the fan doesn't have to be especially powerful. It just has to be able to move enough air to overcome whatever leakage there exists, either in the dome itself or around the edges or under the bottom edge or whatever. It just, which, I mean, yes, it was made, the same design technology that was used to seal the glazing was used to seal the dome over the lung. It was silicon seal injected into the joints, and so it's pretty darn airtight. Not totally, because there were also external doors that you can go into the dome of the lung. Of course, you're not going into the internal part of the biosphere when you just go inside the dome. There's a walkway which is about more than 15 feet wide between the edge of the dome and the edge of the tank, which is underneath the membrane.
Gotcha.
And so, and then the door that's there is not perfectly sealed. It leaks a bit around the edges. So the fan that's in the side of the a dome, it just has to basically blow out enough air to make up for that leakage of air around the door and other leaks that may exist.
Gotcha. I actually watched a video earlier today of John Allen walking out of the like middle part of the lung and into the area under the weather cover. And as he opened the door, the microphone was like blasted by all of that wind because there was like a constant airflow outside. And then he pushed the door shut and you could hear him again. But I found that interesting. Like it was a noticeable pressure difference.
Yeah.
Yeah. Okay. So I wanted to know, in the original 2-year experiment, it was obvious that the biosphere itself was essential to preserving the Biospherians' lives. But how essential were their bodies to the rest of the ecosystem? And this might not be in your area of expertise, so that's fine if you don't know, but I was curious.
Well, it certainly was. I mean, there was, um, well, it depends what aspects of the ecosystem you're talking about, because plants are very different than animals, of course. Animals are very similar to human beings, is that they breathe in oxygen and exhale carbon dioxide. And plants do exactly the reverse. They need carbon dioxide in order to grow with the energy from sunlight. And by photosynthesis, they produce oxygen. Um, so plants can tolerate carbon dioxide much, much higher than human beings can. Although, as I mentioned before, it's not so much that they're very sensitive to carbon dioxide, it's more that they would be suffer if they lost oxygen.
Sure.
And certainly we weren't concerned about carbon dioxide up to even 10,000 parts per million, maybe even 20,000 parts per million, although that would become questionable.
Sure.
Here is only about 400.
Right.
So we're talking about at least one or almost 2 orders of magnitude more if we're talking about, say, 10,000 to 20,000 parts per million
Do
of carbon dioxide.
do you remember around what percentage of carbon dioxide was in the atmosphere when the oxygen was injected to the biosphere? Like was it nearer 20,000 parts per million?
No, the most we ever got up to was around 5.
Oh, okay. Okay. Interesting.
And the first injection was in January of 93, and that was at a high time. So it was right around 5,000 parts per million.
Gotcha.
The oxygen injection didn't change that.
Yeah. Right, because it only injected oxygen and it didn't take any carbon out, right?
Right.
Right. Okay. Interesting. So you agreed with the idea that Biosphere 2 might need a successor, but you took that idea a few steps further. You told me that you thought there should be many biospheres, varying sizes, built globally. So what were you sort of envisioning these kind of biospheres would look like, bigger or smaller?
Well, I think there should be lots of different, obviously hardly anybody can afford, $100 million or something like that to build a big biosphere. So, a college or university or even a high school um, could or should, in my view, make a desktop version. And but of course, such a thing couldn't be anywhere near as complex because you couldn't include human beings, for example, or basically any large animal. I mean, you would probably start off with insects or maybe a lizard. I don't know if you get up to the level of a mouse, that would be quite ambitious. But but up to a room size, or maybe a very large room, or you know a a big desktop version, and all sorts of sizes. Seems to me that for education, it would be really good to do lots and lots. And since, of course, to do lots and lots, some of them have to be very affordable.
Yeah.
And so for college or even high school, it seems to me this is such a fundamental thing. We live in it where, they say that a fish has no concept of water. Well, I'll say the same thing, that human beings have no concept of air. Uh, that um, we basically don't notice air. Yes, of course, we notice there's wind, and we're aware, if you hold your breath, you're very aware of the fact that you're getting out of breath, and so on. So I won't say it's too strong a statement to say they don't have any concept, but nevertheless, I think hardly anybody has much concept of what air is.
Sure.
Um, for example, we don't sense ordinarily that there's 14 pounds per square inch of pressure. I mean, a square inch, that's, and you press on your skin with a force like 14 pounds, it feels like a real hard push. But of course, you don't feel that because it's coming from all sides, and the pressure is balanced by the pressure coming from the opposite side all the time. And you basically never feel that.
Mm. Yeah. And there's also some sort of, I would argue, disconnect between people living their personal lives with air, when they might understand that they're inhaling and exhaling air, but then not understanding that the whole biosphere one that we live in is affected by the factories that we make, the cars that we drive. And I was reading Jane Pointer's book, The Human Experiment, and she sort of describes a shift in her understanding when she entered the biosphere, similar to the overview effect that astronauts have when they see Earth, where it's sort of she noticed that every breath that she took that was critical, because not only supplying herself with oxygen, but she was supplying the biosphere that she lived in with carbon dioxide that it would need to do photosynthesis. And she sort of realized, like, these changes that I make with my body in the biosphere are actually so quicker realized in Biosphere 2 than Biosphere 1.
Yeah. Well, I would argue with her about saying that she noticed when she went in. I would say the fact that she had worked on the project for years coming to that, and then went to live inside, made her think about it a lot. And of course, but I wouldn't say that the moment she went through the door that she noticed.
Sure. It can't be like a physical feeling, right?
Yeah.
Yeah.
Exactly. But yes, of course. If somebody, but uh, but really, a person who thinks about it a lot will begin, or could begin at least, to realize that there are all sorts of things going on here that basically there's no reason particularly to notice, because you live your life and you're doing whatever interests you, and so on and so forth. Uh, but that's why I say human beings have no concept of air.
Yeah.
But
Fair
of
enough.
course, there's also other things like water and food, and um, temperature and humidity and rain, and all these things, which we just become accustomed to since they were always there ever since we can remember.
That's true. I'd say the one time that I noticed air, the very first time that I sort of noticed it, was last summer. I was going on a cross-country road trip with my mom, and one of our destination points was Biosphere 2, but unfortunately we couldn't make it on that trip. I am going this winter though. I'm very excited about that. But the whole trip, we had expected it to be like so hot, because it was going to be very hot, like a lot hotter than we were used to. But we actually found it a lot easier to sleep in the tent than we're used to in North Carolina, throughout the entire trip until we crossed the Mississippi River. And the humidity just like hit us, and we were like, oh, it's actually less hot here than it was all the way in California, but you can feel it so much more now that the humidity is there. It sort of gave me a new appreciation of how much humidity can really affect that. But still, I take your point for we don't notice it. It's not tangible to us, so it's harder for us to understand that it's something we need to protect in our biosphere.
Yeah.
Yeah. So you said smaller, even desktop sized, perhaps, biospheres could be made for educational purposes. Do you still think that there is a place for large biospheres, such as Biosphere 2, to be built? Do you think they still serve a purpose?
Well, sure, because if you get much bigger, you can include much more complex ecosystems. And so if you're going to contemplate living on off the earth, for example, and maybe I should back up a minute, because people have talked about that idea for a very long time, for decades, or maybe even a century. I don't know. It's understood that it was understood for quite a long time that the Earth has a whole complex life support system. It's another thing that hardly anybody ever really thinks about. And only slowly, with a great deal of study, have we, and when I say we, and it's not very far from everybody, come to understand how intricate and complex our whole life support system is. Okay, so if you're going to support a human being, even one human being, let alone several, you've got to have enough to basically, you've got to grow plants to provide your food. That, assuming you're going to do that without simply resupplying eternally from Earth, you got to have enough to grow your food. And then, of course, if you study agriculture, how much of an area do you need to grow food to support a human being? And it's not small. It's, and NASA has tried to address this question, and I don't actually have the number in my head, but even if you get down to hydroponic plant growth and concentrate everything and so on, it's still a pretty good sized chamber. It's I don't know, a few hundred square feet or something. I don't know what the absolute minimum is. But really say, okay, how long are you going to live off of the planet Earth? Are you going to do it for a week, a month, a year? Or are you really going to contemplate the idea that there could be a permanent colony where you have people living off of Earth, where essentially all of their needs, which are more than just food. I mean, certainly food is basic, but you've also got to supply their breathable atmosphere and fresh water. And then when you start to really think about it, who knows what else? And really, aren't people going to go crazy if they are living in a little tin can? Even if those materials they need are there, don't they really need some space to move in? And some sort of scenery, and who knows what else. I mean, it begins to get pretty large.
For sure. You sort of answer a question that I had a little bit later, asking like if we could just, in fact, the question itself, it says, if we just wanted food and basic atmospheric recycling in space, we could grow simple plants like lettuce and hydroponics and employ a CO2 scrubber, maybe using some algae to scrub our atmosphere at most.
Well, but I'm going to interrupt you for a
Yeah,
minute because you certainly can't live on lettuce. You've got to have protein,
this is true.
and you've got to have starches. And so, how are you going to get protein? Well, you're going to do it all with beans, for example. You're going to have a totally vegetarian diet, or are you? I mean, yes, it's just simply measuring the input and output of food and keeping your body metabolism going, you could. But what's your life going to be like if that's all you have? So aren't you going to want some animal foods? And then what are those going to be? Are you really going to want to eat insects? Or are you going to want to eat what? Mice? Well, maybe. I mean, if that's all you could get, you'd probably rather have mice than a chicken, for example, or a fish. But nevertheless, really, what's your life going to be like if you're going to really live your whole life? You know, and then are you going to reproduce? You're going to have babies, and what are they going to? What's their life going to be like growing up from infancy to adulthood, and and et cetera? And if you keep asking all of these questions, where do they go? Now, a baby that is born in a spaceship, for example, and that's all they ever knew, and that's how they grew up, maybe they would be satisfied. But then what would you have? Wouldn't the adults who raised those babies have memories of what it was like on Earth? And they would probably show movies. And in the movies, they would show landscapes. And then the child growing up would say, "What's that?" A landscape. And they would see things like herds of cattle or antelope or birds, and they would say, "What's that? What's that? What's that?" And then, of course, that's going to trigger all sorts of desires and things that they want.
For sure.
And you just keep going with asking those questions of what are the consequences. And I think you come to the conclusion that it's not adequate to just live in a tin can and get your food and breathe your air.
Okay. There's
So
like a whole psychological side to it that you have to consider, I guess, what you're saying. It's funny that
exactly, and
yeah,
and so so all of that was underlying the idea of why we built Biosphere 2 as we did, because we figured all of those factors were very important.
I like coming to that conclusion. It makes me happy that to think that it's out of necessity rather than just overspending, that if we were to make space colonies, they'd have to be beautiful in this kind of way. In fact, right next to me, I have a book called The Higher Frontier by Gerard O'Neill.
Yeah.
Have you heard of Gerard O'Neill?
Yes.
Yeah, I assumed you had, but I'm sure the numbers for how much land you need to support one human are in this book. I probably couldn't find it in time, but if this entire on the cover, this entire space station was to support, say, 1,000 people, this entire section here, I know from his illustrations, is just for growing crops. So
Yeah.
it is a significant amount.
But for how many people?
True. Yeah, I'd have to get the right number for that. He was very ambitious in his predictions. He expected us to be living in space colonies by now, which I really wish we were. But I hope we are within my lifetime. That'd be pretty cool. If if there were to be a second, or hopefully many more, large-scale biospheres on the scale of Biosphere 2 or greater, would it be more cost-effective and effective research-wise to restore Biosphere 2 to its initial airtight capacity, or would it be more cost-effective by your predictions to just build a whole new one?
Oh, I'm sure it would be a lot cheaper to restore Biosphere 2. I don't think it'd be trivial, but but sure. Uh, I mean, because it's sort of like 90% of it is there, and or maybe 99% of it is there,
Sure.
and so yeah.
If we wanted to build a Biosphere 3 that was more trying to be more accurate compared to what we now predict a Mars base would look like more of an analog, what biomes do you think are most essential to include, assuming they had to downsize?
Well, this again goes to the whole line of questions that we were talking about, like how well and for how long a duration would you expect the people to live there, and how many people? So, so you just have to kind of come to some resolution where you're going to be on the spectrum of just the absolute minimum of providing food and atmosphere up to providing a place where people can feel they have a recreational aspect in their lives. When I say recreational, I mean just the pleasure of looking at larger space and scenery than just the cubicle they live in.
Sure. Yeah.
Yeah. And so I kind of can't answer that. It's
Sure.
like, so you're going to have to make some choices there. And basically, these are largely, well, there are two kinds of trade-offs. There's trade-offs in terms of cost, and there's trade-offs in terms of doing adequate research and developing understanding enough to do something more complex.
Sure.
And that's why I say that to really do biospheres for living off of the planet, and I kind of go back to the fundamental idea. When people talk about that, they're, if they're innocent, so to speak, what they're really thinking of is having a world off of the world. Literally having, there's a recognition that there is life support depends on a whole complex ecosystem. And they have that idea that, well, could there be a world off of the world? And they begin to think about, well, could there be an enclosure like that? And then it's the reality of cost and difficulty and everything associated with that that forces them down into this small container. And I'm not saying any of that is wrong. I mean, I'm saying that yes, those realities are real. That it's, if you go to a space agency, for example, and work there and get engaged in all of the questions that arise about not only what would it be like to live, or how do you build something like that, and go further and say, well, how do you actually shoot something like that into space, or land on another planet, or on the moon, or somewhere, and really deal with the problems of doing that, you will feel the pressure of downsizing and downsizing and downsizing, and trying to figure out, well, what is the absolute minimum that's really, really necessary, because you will very quickly learn that the costs of doing something like Biosphere 2 on Mars or the moon or in orbit, the real costs of doing that are enormous. I mean, you know, at least 1,000 times, maybe much more than 1,000 times more than it costs to build Biosphere 2.
Right.
Maybe 1,000,000 times more. So are you going to spend $100 trillion? Where are you going to get $100 trillion? You're going
Right. I don't think Ed Bass has that much money today for something like that.
Yeah.
Right. That's what I like so much about Gerard O'Neill's book, is that he's like initially optimistic, but then he works around downsizing in such a way. Like he really keeps those massive like moonshot estimates, but in that way he still makes them practical. But yeah, I understand that entirely. So when it comes to building these sort of large moonshot projects off of Earth, obviously it would be much more expensive. But on a more practical level, what would do you think that the surface of Mars is better suited to having one of these biospheres on it, or orbit around Earth? I mean, if you think about it, in your paper you wrote, there was a lot of factors on Mars that wouldn't exist in space, like sand abrasion, like damaging the windows of any sort of greenhouse, and then letting even less sunlight through. And you'd get more sunlight in space initially. But I was just wondering your thoughts, like, do you think that the first biosphere will be built in space or on Mars?
Well, I don't know about what will be first, but I think probably on the surface of a planet, and Mars is the most likely candidate. So yeah, I tend to think so. I mean, there are these images of gigantic donuts that are orbiting, that are rotating in space. I think the idea of doing that is probably way more difficult than building, say, on Mars. For one thing, on Mars, you're going to find ways to make use of local materials, which you're not going to have any in outer space.
Sure. Yeah, I think to me it'll be interesting to see SpaceX and Blue Origin sort of compete to get off Earth first. I mean, obviously they're both off Earth now, but SpaceX is trying to get to Mars, and Blue Origin is just trying to get to Earth orbit to build these habitats. It'll be interesting to see
Yeah.
who does what.
Well, I think it was SpaceX that was talking a decade or so ago. They were talking about one-way trips to Mars, which, in my opinion, was essentially a suicide mission if done in any time sooner than the next at least 50 years, if not much longer. I point out something about Mars, which is the gravity, I think, is only about a third of Earth. So that could be really a serious problem. Now, these gigantic donut-shaped orbiting things are rotating space stations. In principle, I won't say easily, because of course I've never gone, but in principle, you have the idea that gravity could be whatever you want by the speed of rotation. But on Mars, you're stuck with 1/3.
That's true. Yeah.
That could very easily be a really, really serious problem for human beings, maybe even insurmountable in long-term habitation. We don't have a clue of what the long-term effects of very different gravity is. Not really. I mean, sure, there have been astronauts who've been up there for, I'm not sure how long, a year, more than a year, I think,
Mhm.
500 days or something like that. I'm not actually sure. Um, and the idea that a human being would essentially go and live in 1/3 gravity for many years or their whole life, um, I think there are massive unanswered questions about the effects of that.
Yeah. I just finished Scott Kelly's book, who's the first person to spend a year in space. And he described after he came home, uh, like the actual mass of his muscles, and body fat was actually like sinking to his legs because over that year it hadn't needed to, I don't know the exact science behind it, but it hadn't needed to like resist gravity and stick to his bones. And that was very scary to read.
Yeah.
Yeah.
And yeah, and undoubtedly had a very rigid exercise regime
Hmm.
that he had to do. And if he didn't do it, it would have been even way worse. But that doesn't solve the entire problem. That's essentially dealing with muscles. But your body is a whole lot more than just muscles.
True.
And I haven't read his book, and of course, or I haven't read any of the medical studies about what kind of effects there have been, and so I don't really know what those answers are. But I could very well believe that they could be very serious. And by the way, um, somebody mentioned a few months ago that I was in um, a, uh, a kind of a conference to do with living in space, and somebody mentioned that people have had the major radiation exposure, that people, the life expectancy of people who astronauts is way lower than other people.
I
And
suppose,
even on Mars with an atmosphere, I'm sure the radiation is much higher than on Earth.
I suppose Mars is a little bit inconvenient in that way, in that, I mean, it's convenient in when it comes to radiation because obviously you get less radiation than the International Space Station because you're still within the planet's electromagnetic field. But still, it's enhanced. But I feel like Mars is sort of inconvenient going back to the gravity discussion because it's not enough gravity to sustain a human body, but then it's too much gravity to be able to easily launch to and from space. Which I suppose if you have a self-sustaining colony on the planet, you wouldn't really need resupplies from space, but I think it'd still be convenient. But yeah, radiation wise, I don't think you can really escape that. It just comes into shielding, which is a nice thing about biospheres, is you already have a ton of water on you, which is a great radiation shield to support these ecosystems, and you can
Well,
just use that.
well, you could if that's the way you designed it.
Mhm.
I
True.
mean, Biosphere 2, you didn't have any water, you had glass, which is something, but I don't really know what the radiation attenuation is of a half inch of glass.
Sure, sure. That's one of the considerations that I guess you wouldn't have to make for an Earth biosphere. But I guess once you're going to Mars, it's quite a bit different. Although I'm sure biospheres are contributing a whole lot to our understanding of what a biosphere might look like on Mars, which I think is one of the most interesting parts of these. What do you think Biosphere 2's largest contribution to the world of science or society? Just what do you think its largest contribution to our understanding was?
Well, just waking people up a little bit. That is the people who managed to pay attention and think about it a little bit. Um, uh, Hopefully that goes a little bit in the direction that I brought up when I was saying people have no concept of air. Um, of course, that whole question is sort of symbolic of much larger questions, about how are we sustained on this planet. Um, but just that little nudge of awareness that Biosphere 2 has made with among those people who have managed to pay attention to the whole idea is meaningful.
Yeah. All right. Last but not least, when I go there in a little over a month now, is there anything I should look out for that isn't included on the tours or that most people don't know about? Any secrets that you can tell me?
Well, I think pretty much. I mean, you'll want to make sure you go to all the areas, like including the lungs, of course, which you might not unless you make it a point to. And I suppose you might take multiple tours when you're there. There's a small detail. There's a place kind of right in the middle where there's a very, very large airlock, like 20 feet square type area that used to have a big metal panel bolted over it. And if you look at the flanges of that, if you're inside Biosphere 2 and you see the flanges where that metal panel was bolted, you'll see the flanges are turned a certain way and they're spaced out from the wall, and then there are all the bolt holes. Okay, the reason for that is that what I thought of was that if you're going to try to have a wall that's between the inside and the outside, and you're going to try to seal that by bolting a plate over the opening, and you're going to have the bolts go through from the inside to the outside, then that means you've got to seal the whole perimeter of that bolt.
Right.
And since there are dozens or even hundreds of the bolts to make the entire flange, that means you got to pay attention to sealing every single one of those bolts. So instead of doing that, what I said is on the wall, come out a distance, I don't know, 4 inches or 6 inches or whatever, and then turn the flange and then bolt the panel to the flange so that all the bolts are essentially going from inside to inside instead of from inside to outside.
Huh. All right.
That,
what part is that in again?
it's right in the center where down in the passageways, which we call the infrastructure. That is the basement areas where all the mechanical equipment is.
Sure.
And you'll see that that's an example. I did the same technique at the edges of the lungs, the circular rim of the tank where the membrane goes. Put a flange that's turned like that, and then the membrane goes like that, and then the bolts go from inside to inside instead of from inside to outside.
Super interesting. Thank you. Thank you. Now I have something to look for, and I'm gonna be like, y'all don't know that, but I do. That's awesome. I'll say Bill Dempster himself told me that.
Yeah, right.
And you'll be happy to know that I did get every single tour that they offer scheduled throughout the day. So the self-guided tours and the guided tours. So we're gonna be able to hit the crew quarters, the library, the lungs, of course, in addition to all of the main parts like the ecosystems. Yeah. So I'm so excited. And thank you again for taking the time out of your day to call me and talk about some of this stuff with me. It's been really awesome.
Well, I'm really glad you're so interested. That's good.
I appreciate it.
That's great.
All right. You have a great day, Mr. Dempster. Once again, thank you so much. All right. Awesome. Sure. I appreciate it. Have a great day.
Okay, great. Take care.